Welcome to your future. Welcome to Vision Academy. Let us unlock your full potential.
When you finish a math problem, you usually have to wait for a grade to know if you are right. But with certain problems, you can use the numbers themselves to confirm your work is correct before you hand it in. Today, we are calculating the lowest common multiple and the highest common factor for three specific pairs of integers. We will use a specific property to check our work. The product of the LCM and HCF always equals the product of the two original numbers. Have your pencil and paper ready. We're going to find the prime factorizations and test this rule together. Learning this verification method helps remove the guesswork from exams by giving you a way to audit your own results. We'll start with our first pair of integers, 26 and 91. First, break both numbers into prime factors. 26 is 2 times 13. 91 is 7 times 13. The highest common factor is the shared prime, 13. The lowest common multiple multiplies every unique factor, 2, 7, and 13, giving an LCM of 182. Remember the distinction. The HCF focuses only on what is shared, while the LCM must account for every unique factor involved. Now we apply the verification rule to see if our factors are correct. On the left, we multiply our results. 182 times 13 equals 2,366. On the right, we multiply our original numbers. 26 times 91 also equals 2,366. Because these totals match, we have proof that our LCM and HCF are accurate. This identity is a property of integer pairs. It acts as a reliable check on your factorization steps. Verification becomes even more useful as numbers get larger and mental math becomes difficult. Let's try 510 and 92. Here are the prime factorizations. 510 is 2 times 3 times 5 times 17. 92 is 2 squared times 23. The only common prime is 2, making the HCF 2. For the LCM, multiplying the highest powers, 2 squared, 3, 5, 17, and 23, yields 23,460. When numbers are this large, a single mistake in basic multiplication can throw off the whole verification. Check your digits carefully. Testing the rule, 23,460 times 2 is 46,920. Our original numbers, 510 and 92, also multiply to 46,920. Let's move to our final pair, 336 and 54. Factorizing, 336 is 2 to the 4th times 3 times 7, and 54 is 2 times 3 244, matching 336 times 54. Regardless of the size of the members, the relationship between these factors remains consistent across every pair of integers. Look back at your work. You have now successfully calculated and verified 3 different sets of numbers. On a test, if your verification equation doesn't balance, you know immediately to go back and spot an error in your prime factors on multiplication. This rule works for pairs, but consider what happens when you add a third number, like 12, 15, and 21. The verification process changes as the complexity increases. Mathematical confidence is built by using tools like this to detect and correct your own mistakes independently.
Like this video? Subscribe to our channel. Share this video. Thank you. Shukriya.